What's going on, guys? Today we're going to be talking about different techniques that we could use in our linked list. First, I'm just going to show you that I have a linked list file already created, and there's a node.java file as well, which is associated with this file. So this part is very essential, and if you didn't watch my linked list video, I encourage you to check that out first before diving into this one. That link is available in the playlist. And you could also check the video out by clicking on the card on the top right corner. 2-pointer linked list techniques. First technique we're going to talk about is the 2 pointers moving in parallel technique. We know that many common singly linked list problems can be solved by iterating with 2 pointers. This is sometimes known as the runner technique. Create a method that returns the nth last element of a singly linked list. Now, how are you supposed to know the nth last element? Suppose I say to you, return me the third last element of a singly linked list. You'll need a method of calculating your distance from the list's end in order to accomplish this. There isn't a convenient way to iterate back through a singly linked list when you reach the end though. Because we know that the singly linked list is moving from the start to the end. It doesn't go the reverse way around. Suppose we have some array list here. So suppose this is our linked list, and we want to copy the entire elements into this array list. You could do this, and then from there you could find the nth last element. And I'll tell you how this is possible. And once we want to get the nth last element, we could just get the size of the array list, and then we could minus that with the nth last number you want. Suppose when the array list says I want the second last element, we know that the size of this list is 3, and the indexes start from 0, 1, and 2. Well, we have to minus the size, so let's say 3 minus 2, and that gives us the index 1 for this one, which is the second last element. So that's how we could solve this using the array list. Although this method produces an implementation that is simple to comprehend, keeping a dual representation of the same data could consume a lot of memory. To keep track of a linked list with 1,000,000 nodes, you'll need 1,000,000 pointers in an array list. An additional O of n space is allotted when using this method. So this is not a good method at all. So we would use public static node, and we're returning with node array nth last. We pass in the linked list, we pass in the number which we want to get. Suppose we want to say the second last element. We create the array list node, but I don't have array list imported, so I could just do quick picks and import array list. That would be imported on the top over here, so import java.util.arraylist, and that removes my error from here too. And since this is static, it doesn't require an object to be created. So array nth last, you just create an array list. The type of it is node, so that it could hold nodes, and then after that we have linked list array, new array list node. Once we do that, we have node current node, and we point that with the head of the list. We iterate that node until it's null, and we say that linked list array dot add current node. So we add the current node inside of the array list that we created. We go forward, we traverse our current node to the next node until that node reaches null. Then we return the linked list array. So linked list array, which was created here, dot get, which is the method in an array list, and then we say array list dot size function, which could be like 3. Suppose we had 3 elements, and then we said we want the second last element, so we say minus 2. So 3 minus 2 is 1, and that's the index what we want to get, and that would be returning the node that we require. So this is a solution, but I told you like before, it gives an additional O of n space. So this issue can be resolved by utilizing 2 pointers that are placed at distinct locations inside the list, but move at the same speed. So what we will do is we will move the second pointer n steps behind the first one, while still using 1 pointer to iterate the full list. So we'll have 2 pointers here. Suppose we have 1 pointer, I'll just use the number 1, and that's 1 pointer over here. And we also have a 2 pointer, so this is a second pointer. And we'll have 1 pointer that will iterate the entire list, and the other pointer will just actually be behind of it. So let's go to the code. Here we have public static node nth last node. We pass in a linked list, and we pass in the number that we want. Suppose we want the second last element, so we passed in 2 over here. We create 3 different variables. One is the current, which points to null. One is the tail seeker pointer, which points to the head. And the other is the count, which is equal to 0. Like I said with our example over here, we had 2 pointers, 1 and 2. So the one pointer is pointing to the head. The other pointer is currently right now pointing to null instead of the head. And we'll adjust it and we'll point to the head in the future, because we're gonna have to use some kind of technique. Our main goal is to make this one traverse the entire list, while this one will keep its pace as it is. So just go back and we'll see. Now that we have this while loop, we say that tail seeker is not null, so we actually want to traverse the tail seeker. And that tail seeker is the one that we were talking about. The first one is the tail seeker, and it wants to move till the end. So it goes tail seeker dot get next node. We know that get next node means to get the next node, and assign it to the tail seeker. The count over here, let's look at this count. Because count was 0 over here, it will just increment, and it will just increment all the time. It's a tracker for us. So in the condition here, it says count is greater than or equal to 0. In our case right now, the count is 0, and the end number, suppose we say the second last element is 2. So the 0 is not greater than 2, so this condition won't even run, this one entirely. And the count will increment to 1. And then again, the tail seeker is actually now 2 steps. This is the other one, the current node, and that's pointing to null. So the tail seeker is over here. I'll just call it tail with the T. Now it's moving, it's in the first one, which points to the head. But after this line, you could see that the tail seeker went to the next node. So we could say in one iteration it went here. And then after that, once the incrementation was done, this tail seeker now will go one more step to the next portion. Since the counter is now 1 and 1 is not greater than or equal to 2, it's not going to work this again, and it's going to increment the count once more. So the count now will be 2. Now the tail seeker moves one step again. So now instead of this, we'll go here. And you'll see that the tail seeker is not null. It's still well and good. Get next node method will apply again. So now it actually does point to null, because this after this is null. So now it's null. And over here, that this condition will be satisfied. The current is equal to null, so that is true, which is currently null. This will be removed, and now this current node will point to the head. So it will point to the head, and the current will also traverse. So we could say that this traversed to the second portion here. So now this current one will also point to the second, but this tail seeker is now currently at the null portion at the end. So what we could do at the final stage is that we could increment our count, and our count will turn into 3. But the condition that will be checked here is this one: tail seeker not equal to null. Well, tail seeker is equal to null, so this condition is gonna break. And what we'll do is that we'll actually have to return that nth last node. And this is the current, return current. So this is current, which is this pointer here, will point to the nth last element. And that's how our solution is solved. Perfect. Now let's talk about the time and space complexity to this problem. The exact variable names aren't important, and the internal implementation could be written in a number of ways. The important part is that we were able to complete this problem efficiently in O of n time. We must iterate through the entire list once. And O of 1 space complexity, we only use 3 variables, no matter what size the list is, 2 pointers, and a counter. So that was our implementation, and I hope you got it through. I hope it was easy to solve. And if you have any questions regarding this, let me know in the comments.